Assalamu alaikum students. Today we are discussing the think tank, and this think tank is given in the chapter number 12. Name of the chapter is hydrocarbon, and this chapter is given in chemistry syllabus recommended for the 10th class. See the first question of think tank. Question number 11. This is the first question of think tank, and this is the 11th question according to review exercise. Write chemical equation for the preparation of propene from propanol and propine. In order to prepare the propene from propanol, we must have the process of dehydration of alcohol in the presence of aluminium trioxide as a catalyst, and we are heating the propanol at 340 to 450 degrees centigrade. As a result, water is evaporated and dehydrated, and we will get double bond product propene. B part, propine. We can prepare propene from propine by hydrogenation. This is the addition reaction. We can add one molecule of hydrogen across the triple bond and convert triple bond into double bond structure, and this could be happen in the presence of nickel as a catalyst, and temperature is 200 to 300 degrees centigrade. Now next question, write down the structural formula for the products which are formed when 1-butene is reacted with water, with hydrogen and nickel, with dilute alkaline aqueous KMNO4 solution, bromine water, and chlorine. See the first part. The structural formula for the product obtained from 1-butene when it is reacted with hydrogen in the presence of nickel as a catalyst, and the temperature is 200 to 300 degrees centigrade. For this reaction, we will added one molecule of hydrogen across the double bond and converted 1-butene into butane. See the B part, dilute KMNO4 solution. The structural formula for the product obtained from 1-butene when it is reactive with dilute alkaline aqueous KMNO4 solution is, we are having 2 KMNO4 plus 2 molecule of water and 1 butene. We will get a butylene glycol, and this could be a this and two OH groups are occur across the double bond and convert into a single bond structure, and we are having 2 manganese dioxide and 2 KOH. See this, these both of these reactions, these are the simplest reaction. Now C part, structural formula for the product obtained from 1-butene when it is reactive with bromine water is given. Here again halogenation would be occur across the double bond and converted into double bond 1-butene into single butane, and this product is 1,2-dibromobutane. D part, the structural formula of the product obtained from 1-butene when it is reacted with chlorine. The same in the same way, the double bond one molecule of chlorine is added across the double bond, and we are getting 1,2-dichlorobutane. Both of these reactions are same. We are only having the different halogen atom. In case of C part, we are having bromine water, and in case of D part, we are having chlorine. Otherwise, both of these are the halogenation of alkenes. Now, question number 13. Identify A, B, C, D in the following reaction. The product is propene. There is again halogenation, and we are adding bromine molecule across the double bond and converted into 1,2-dibromopropane. Then 1,2-dibromopropane react with KOH, and we are getting KBr water and intermediate product of bromopropene, and that is bromopropene again react with KOH and convert into propine. This is the preparation of alkyne. Now look at the second part, ethyl alcohol. And in case of ethyl alcohol, if we are having concentrated sulfuric acid, it's mean that this is the alcohol's dehydration one molecule of water is removed and converted ethyl alcohol into ethene, and this could be happen in the presence of 140 to 170 degrees centigrade temperature. And now reaction of ethene with bromine, again we have halogenation and double bond structure is converted into single bond, and we are having 1,2 dibromoethane. See all of these four reactions. Now question number 14, construct a scheme to convert ethene into ethine. In order to construct a scheme or conversion, we have at least three reactions. First of all, we convert ethene into dibromo chloroethane, and then we have the preparation of alkyne. When we convert 1,2-dichloroethane ethene into 1,2-dichloroethane, we must have the reaction of ethene with chlorine, and that 1,2-dichloroethane react with KOH alcoholic, and we are getting intermediate product chloroethene. And this chloroethene react with KOH and convert into ethine plus KCl plus water, and this is again the preparation of alkyne by dehydrohalogenation. Question number 15. You are given two flammable liquid hydrocarbons. One of them is an alkene, another is alkyne. Design an experiment to find out which is which. For this question, we take two test tubes. In one test tube, take sample of one flammable liquid. In another test tube, take sample of another flammable liquid. Add bromine water in each test tube. Observe the color of the sample placed in both test tubes. When bromine water disappear, when the color of bromine water is disappear, then it is alkane, and while when no color change take place, then it is alkane. See the halogenation of both alkane and alkene. In case of alkene, we have colorless 1,2-dibromoethane, and in case of alkane, we have 2 carbon plus HBr, and this could be happen in the presence of strong sunlight. Question number 16. How many possible products are there when chlorine react with ethene? Sketch them. Sketch them means we have to write all of these six reactions. This reaction, these reactions are displacement or substitutional reaction. We are adding one chlorine atom and replacing one hydrogen atom. C2H6 plus Cl2, we are getting C2H5Cl, and all of these five reactions resultantly at the last we have C2Cl6, and all of these six reactions shows displacement or substitutional reaction. See all these six reactions. Question number 17, differentiate ethene and ethine. Look at the reference. Reference should be in column. Ethenes are unsaturated hydrocarbon having carbon-carbon double bond, and their formula is C2H4. Ethene react with KMnO4 to produce ethylene glycol. In case of ethine, ethynes are unsaturated hydrocarbon having carbon-carbon double bond, and its formula is C2H2. Ethylene Ethene react with KMnO4 to produce oxalic acid. These are two points in each, and at the third point we must write the reaction. In case of ethene, we have single reaction. Two molecules of ethene react with 2 KMnO4 and 2 molecules of water. We are having ethylene glycol, 2MnO2 and 2 KOH. But in case of ethine reaction with alcoholic KOH, we are having we are having three reaction. 4 KMnO4 react with KOH, and we are having 4 atom of oxygen. Out of these 4 atom, 2 react with um, ethine and converted into tetrahydroxyethane. Tetrahydroxyethane is unstable and removing 2 water molecule, and this glycol react with 2 atom of oxygen and converted into oxalic acid. This is the final product, that is oxalic acid. Thank you.